we have this mutual friend, Sabine Hassenfelder. And Sabine has this very strange feature of her personality that she needs to tell the truth at scale.
Oh, well, Sabina is a scientist, and scientists, engage in the truth at all costs.
Yes, but
it's sort of our modus operandi.
Well, I find it very interesting that almost no one has followed Sabine's lead.
I think it's Sabina.
Sabina?
Yeah.
Okay. From her perspective, beauty has led theoretical physics astray.
Right.
Now, I've tangled with her. My claim is that the string theory community, which has generally hoovered up the most brilliant minds, but turned them into kind of almost cult-like members, which are exploring some structure, but I just don't. It's similar to E8 in the sense that I'm not positive that it's the structure of our world. It has some beauty and some consistency, but I'm not positive that that's its reason for being. And because that argument has been so abusive, and it's been abused against other people, that our work is beautiful, and then when those outsiders look at it, it doesn't look like what you're doing is that beautiful at all. She's gone against beauty as a means of trying to figure out what's true and what isn't. I'm concerned that you're falling prey to the siren of beauty, where you're not things that are beautiful, that there are many things that are beautiful that don't exist to do what you think they're there to do.
Right. Well, that's definitely true. I'm definitely inspired by beautiful mathematical objects. When I start exploring an area of mathematics and I start to see its intricacies and its connection to fundamental physics, I am led to think that there might be something there based on aesthetics. Well, and I've also discussed this with Sabina, who I think is great, and her points are wonderful, but I would be lost if I didn't have this aesthetic sense as a guide.
Well, let's take an example like the hydrogen atom. So you've got one proton at the center of a hydrogen atom, and you have all of the electron shells in quantum theory that are generated by the Coulomb potential that comes off of that nucleus, right?
Right.
Okay. That story of chemistry as just being these perfectly spherical electron shells works pretty well.
Well, you have the other orbitals, p orbitals, s orbital, d orbital, all these things, yeah.
Yeah, in terms of the representation theory of something we'd call spin 3 that gives the symmetries of this system. That story is not, it is absolutely gorgeous. It's beautiful, and it works pretty darn well. Mm-hmm. But it starts to fall apart the larger the atoms are, and the more neutrons and protons are stuck together in the nucleus.
It gets much more subtle, yeah.
Well, it's a perfectly beautiful story that isn't the right story. It's not the true story. It's very close to a true story. It's suggestive. It's indicative, but it isn't actually the true story itself. So you have to be very careful, in my mind, that you don't fall into the trap of thinking that the hydrogen atom sort of generalizes its perfection is simply the story of chemistry.
Right, of course. They're much more complex elements, and then grouped into molecules, and there's all sorts of things that go into that sort of chemistry.
Well, but don't you have the same situation in theoretical physics, where you have certain kinds of beauty that are incredibly pure that actually kind of fall apart under scrutiny, and you have other kinds of beauty that seem to fall apart but actually go the distance. I'm thinking about Dirac's discovery of antimatter as the corresponding solutions to the matter solutions.
Right, and didn't you usually think that the anti-electrons were actually protons?
Because they only knew of those two particles. And then Heisenberg tried to pop his bubble and said, you
actually have a new particle here.
Well, no, he said that the proton was way too heavy to be the antiparticle mirror of the electron. And I think Dirac sort of recanted, but Dirac should have had the courage of his convictions and said, I predict that there will be two new particles, an antiproton and an anti-electron, which was called the positron. And both of those things turned out to be true.
Yeah, and that's considered a victory for the aesthetic of beauty in mathematical physics.
Yes, but there was an intermediate situation in which the beauty led Dirac astray because he wanted to shoehorn his theory into the pre-existing world that was understood.
That's right. So it's important to be cautious and careful, but not too cautious. So if the mathematics is actually telling you something, you want to listen to it.
What's the mathematics telling you?
It's telling me that I think I've got the first handle on a geometric description of quantum field theory.
Garrett, I say this out of love and I hope not envy. I'm super concerned that you can see the problems from here, and that rather than just going to infinite dimensions and saying that quantum field theory requires a jump from finite to infinite dimensions, you can say, look, I am fighting the fact that the beautiful unification that I found actually is going to be challenged at the quantum level, where that beauty becomes my enemy.
I would never put it that way.
I know, because what you did is you took a theory. I mean, to be honest, there's a different set of objects called the exceptional isomorphisms, which aren't the exceptional Lie groups, that have the exact same property that you found, where you take something from the force universe. Let's say there's some object called spin 6, which by an exceptional isomorphism is equivalent to some other object, surprisingly, called SU4. And you can take the spinors of spin 6 and find out that they are just the 4-dimensional object from SU4, and smush them together, and you get an analog of E8.
Yeah,
that is also probably not used by the physical universe in any way that we think of as being important. I don't think that feature is what you think it is.
Right, but there are a vast world of mathematical possibilities out here, and I think we need more people.
I totally agree with you that we need more people fanning out and trying things that look like they won't work.
So we need a more exploratory culture.
We need a more exploratory culture, and we need to be forgiving. What we don't need to do is to fool ourselves when we start getting the sense that maybe this stuff doesn't actually work. I mean, it feels to me like I can sort of see what the next set of problems are going to be, and I would be remiss if I didn't say them at the beginning.
Sure.